Learn the basic building blocks of TypeScript while discovering firsthand how TypeScript can make your life easier and your code less error-prone. Popular instructor Bob Zarol teaches this course. TypeScript is a superset of JavaScript, meaning all valid JavaScript code is also valid in TypeScript. However, TypeScript enhances your coding experience by enabling you to write code with greater confidence in the stability and longevity of your projects.
Hi there, and welcome to this introductory course on TypeScript. My name is Bob Zarol, and I'll be your teacher through this course, guiding you through learning one of the most important things you can learn as a front-end web developer. Now, there might be a lot of reasons why you're here in this course trying to learn TypeScript, but I'm going to give you 3 of the most important reasons you can learn TypeScript. The headliner reason for learning TypeScript that I would offer is the confidence that it gives you as a developer. TypeScript's ability to check your code during compile time, or using modern IDEs, essentially in real time as you're typing your code, dramatically reduces the number of app-crashing runtime errors that would normally only be caught after your app is running and possibly even deployed live to production. Because TypeScript can catch a lot of those errors before anything gets pushed up live, your confidence as a developer in the stability of your code will be through the roof. Another reason I would offer it's important to learn TypeScript is the added productivity that it brings to you as the developer. Sure, TypeScript does take a bit more time to write than just slinging regular JavaScript code around, but there are a number of really neat features that make your life as a developer a lot easier by simply using TypeScript in your project. In VS Code, for example, yes, in JavaScript you'll get some autocomplete, but you'll see as you're using TypeScript, autocomplete turns up to a completely different level. In modern TypeScript-enabled IDEs, there's also refactoring capabilities, immediate error checking, as we talked about in point number 1, and a bunch of other things that you'll find as you're using TypeScript that just greatly improve your developer experience and thus your productivity. And a third reason I would offer that it's really helpful to learn TypeScript is that it will improve your employability. Assuming you are a junior or maybe even a mid-level developer that is on the job market or will be on the job market in the future, learning TypeScript is oftentimes considered table stakes by many companies, even if it's not explicitly listed in their job descriptions. As such, knowing even a little bit of TypeScript can really set you apart from other junior developer candidates. So what exactly will we be covering in this course? Well, this is an introductory course, and by the end of the course, you will have an understanding of the fundamentals of TypeScript, and we'll be talking quite a bit about why TypeScript is so useful. As far as the topics goes, we're going to cover the basic, literal, and custom types. We'll talk briefly about optional properties, unions, type narrowing, some built-in utility types that exist already in TypeScript, and generics, which essentially allow you to create your own utility types or to make your functions and other types more flexible. By understanding these fundamentals of TypeScript, I truly believe that TypeScript can be a catalyst that helps train your brain to think like a senior developer. As such, there's one thing in particular that I remember when I first started learning TypeScript, and that is that it can be challenging to learn at first. You have nothing to worry about because you're here on Scrimba. You're going to be getting your hands on the keyboard quite a bit throughout this course, practicing really understanding what you're learning. And I've tried my best to really break down the topics into bite-sized chunks that are really easy to comprehend. Still, one of the challenges I have heard from a number of people who are learning TypeScript for the first time is that it feels like we're just adding a bunch of extra work without any additional benefit. Especially if you're trying to convert an existing codebase into TypeScript, it can be quite overwhelming to see all of the errors pop up when you change your file to a TypeScript file. However, as my friend Kent C. Dodds puts it, TypeScript is not going to be making your life terrible. It's simply going to be showing you how terrible your life already is. It's really important to remember that the errors that you see show up in TypeScript, they're not there to bug you or be annoying. They're really there to protect you against some of the loosey-goosey typing that happens in vanilla JavaScript. An analogy that I thought of that kind of helps me understand this better is the concept of building a blueprint or a sketch of a project before you actually start building it. On a large scale, if you can imagine someone trying to just walk up to a pile of lumber and start building a house without a plan, you can tell that that's probably not going to end very well. Yes, drawing out a blueprint, planning ahead, it takes a lot of additional work beyond just building your house. But the benefits are obvious. And I believe after you've been exposed to TypeScript and you've built some projects using TypeScript, you'll probably see it in a very similar way. Maybe to get a little bit more specific, let me talk about what this item is right here. This is called a stud guard, and it's an example of planning ahead of time to avoid catastrophic issues in the future. Now, the idea of a stud guard is oftentimes homeowners will try to find a stud and nail or screw something into that stud, maybe to install some kind of hardware or hang something heavy or whatever it might be. However, in certain parts of our house, it's really important that we don't nail through the stud. If I had a screw that was too long and right here tried to screw into this section, I would hit this water line, or even worse, it could be an electrical line, or even worse, could be a gas line. And so these stud guards, which are made of 16 gauge steel, make it so that it would be really difficult to get through this section of the stud and accidentally cause something terrible to happen. A little bit of extra work planning ahead, just like using TypeScript, can save you big headaches in the future. Now, TypeScript does not solve every programming problem like this meme might suggest. The main focus of TypeScript is on fixing possible runtime errors, more specifically anything that would be a type error. And as I'm sure you've experienced, not every error in your code is a runtime type error. TypeScript can do quite a bit to protect you against the most common errors that people write into their JavaScript code, but it won't protect you against certain things like logical errors. That said, we're about to see firsthand just how many errors we can fix by simply changing a file from a JavaScript extension to a TypeScript extension. I'm really excited to jump into this code. My name is Bob Zarol, as I mentioned. I'm most active these days on X. You can click my username here to go directly to my profile. I'd appreciate a follow. So without further ado, let's jump right into learning TypeScript. When I first started learning about TypeScript a number of years ago, I really struggled with understanding what benefit I was actually going to get by using TypeScript instead of vanilla JavaScript. Writing your code in TypeScript does require a relatively significant overhead in terms of extra lines of code that you have to write and considerations that you have to take. And so for this course, I really wanted to demonstrate the improvements that your code will receive by using TypeScript instead of JavaScript just by itself. So the approach I'm going to take might be a little bit different, but stick with me, it's going to be fun, and I really think it's going to highlight the benefits that you'll get out of using TypeScript. The way I'm going to approach this is by building a really simple restaurant app. It's just going to be console-based, so we won't be worrying about HTML or anything like that. And we're going to start by writing it in regular JavaScript, and I'm going to give you a couple really simple challenges. But again, stick with me, this is going to be really fun. Okay, so we're going to create a pizza restaurant, and the first thing I want to do is create a menu. It'll be an array of items. Each of those items will have a name. And let's go ahead and add a couple pizzas here. We'll say a margarita pizza, margarita, and we'll give it a price. And let's go ahead and add 4 different pizzas. And for the sake of time, I'll speed through adding different pizzas to our menu. All right, in our pizza restaurant, we also are going to want to keep track of the cash in the register. Let's say we start each day with $100. And we'll also want to keep track of all of our pizzas in the queue as people are placing orders for pizzas. This way the workers in the kitchen can know what needs to happen next. So let's say we have an orderQueue, and we'll just initialize that as an empty array. Okay, let's do a quick series of challenges. This is mostly just going to be a way to get your brain and your fingers working right away. So let me type out your first challenge. Okay, this is about as simple as it'll get. Your challenge is to add a little utility helper function for us that's called addNewPizza. It should take a pizza object that's just like the shape of this object up here in our menu, and it's going to just add that object to the menu. Pause now and work on this challenge. Okay, let's add a function called addNewPizza. It's going to take a pizza object. And simply enough, it's going to do menu.push the pizza object. Perfect. All right, we're really on a roll here. Let's get rid of this challenge text. And already it's time for another challenge. Okay, this one's a little more involved, but still very doable. Your task is to write another utility function. We'll call it placeOrder that takes a pizza name, so pepperoni, for example, as a string, and first finds that pizza object in the menu, so this whole object. Then it adds the new price that you just generated as a business to your cash in the register. And it should create a new order object, which is going to be just like this one that you see here. It'll have a pizza property whose value is the object that you got from step 1. And then a status, which we will set to the string ordered. and then it will push this order object to the orderQueue array. And then just for good measure, we'll go ahead and return that new order object just in case we need it in the future. Okay, pause now and work on this challenge. All right, let's do it. We'll have a function that's called placeOrder. It's going to take a pizza name as a string. There's a few different ways that you could do this, but I'm going to grab the selected pizza, and that's going to be the returned result from calling menu.find. .find is an array method. Menu is an array, of course, and .find is a method on all arrays where you provide a callback function. .find will iterate over all of the items in your array. In this case, we'll call it a pizza object. And from this callback function that I get to write, if I return true at some point, then .find will return the object that it found, and that's what I'm saving as selected pizza. So in this case, I'm looking for the pizza in my array with the pizza name that was passed in here. So with pizza object, I'll say if pizza object dot name is equal to pizza name, the parameter passed into this function, then it will return true and I have correctly found my pizza. Okay, then we'll go ahead and increment our cache and register. So we'll say that plus equals the selected pizza dot price. Okay, and that does it for steps 1 and 2. Then we're going to create a new order. And this will be an object that has a pizza property. That's going to be our selected pizza object, and a status, which we will default to ordered. Then we will push into our orderQueue. So we'll say orderQueue.push our new order and return the new order here. Okay, one more quick challenge, and then I promise we're going to get to the point. Okay, in this challenge, we have one more utility function to write. We'll call it complete order. It's going to take an order ID, which will be a string, as a parameter. It will look in our orderQueue array for the order with that ID, and then simply mark its status as completed instead of ordered. And then for good measure, just like we did with placeOrder, we'll return the found order from the orderQueue. As a note, you'll need to make sure that you're adding an ID to the orders whenever you create new orders. Right here, we're not including IDs, so that's an improvement or a modification that you'll have to also make to the placeOrder function. And since we're not using a real database here, you'll just create a global variable called nextOrderId that you can start at 1, let's say, and increment every time a new order is placed. All right, pause now and work on this challenge. All right, let's create a function called completeOrder. This is going to take an order ID. And then before we get too far down that rabbit hole, we'll go ahead and create a new variable. We'll call it nextOrderId, and I'll set it equal to 1 to start. Here, when I'm creating my new order, I'll go ahead and add an ID property, and I'm going to use this trick where I can say nextOrderId++. This will return the original nextOrderId before it gets incremented. That's the value that will be set to the ID here. And then once it's done doing that, it will increment it so that in the future, when I do this again, it will have already changed from 1 to 2, and it will then increment it from 2 to 3 for the next time that it gets used. By the way, for anybody that's shouting at your screen and was probably shouting at your screen when I was doing this line of code as well, I know that there's bugs in here. We're going to talk more about that very soon. So don't worry about me. I know that there's problems to fix. Down in our complete order function, we can do the .find method that we used before. So let's go ahead and say this is our order. We're going to use orderQueue.find. We'll say for each order that we're looking at, we're looking that the ID is equal to the order ID that was passed into this function. We will then change the order's status to completed and return the order. Now, I do want you to use your imagination a little bit here. Of course, we're talking about creating a console-based pizza restaurant, which is, of course, delicious, but also a bit contrived as it stands. But imagine that you've spent the last 30 or 60 minutes, or maybe even a full day or two, working on some new feature for the app that you're currently building, and you now feel like you're ready to start testing things out. So let's go ahead and let me clear up this challenge text, and we'll just test a few things out. We'll add a couple new pizzas. And let's add one of my personal favorites. This is going to be a chicken bacon ranch. And we'll say that the cost is $12. We'll add another pizza and let's call it maybe a barbecue chicken. That'll also be $12. And then maybe let's add something a little spicy in here. We'll call it a spicy sausage pizza. And maybe this one's $11. Okay, and then we will place an order, and this will be for a chicken bacon ranch. And we know ahead of time that our first order ID is going to be starting with a 1, so we'll go ahead and test our complete order, and we'll test the order with the ID of 1. And then in true fashion, let's go ahead and console log everything that we have. So we'll console log our menu just to see if our add new pizza is working. We'll console log our cache in register. And let's check out our order queue. All right, now if you've actually been following along, you know that this code is pretty full of some minor bugs. When you wrote the challenges, you may or may not have introduced similar bugs, but at a glance, if you were to run through this program just reading through the code, I don't think it's that much of a stretch to think, well, this looks pretty good. Yeah, let's push this up to production. We'll run a couple tests and see if it works, and then push everything up. If you took the chance to pause and run this code, you'll know that we're going to be running into all kinds of little problems. First of all, we have this type error assignment to a constant variable. Well, a type error, this is actually something that would crash our program. If somehow this made it past testing or didn't involve any kind of manual testing, it would have gotten pushed to production and our app would have crashed. There's also a bug in the way that I'm testing my complete order. Of course, I used a string. This is, again, a bit on the nose because we know that this should be a number, but this would have probably crashed our program as well. Now, before taking a bunch of time and fixing these errors, this is the perfect opportunity for us to move this project over to TypeScript and first of all, see what errors TypeScript is able to pick up without us making any other changes to the code, and then to dive deeper into TypeScript and see how we can augment our code so we can teach TypeScript how things are supposed to look so that it can catch other bugs that it otherwise wouldn't be able to. So before this bug-laden code gives me any more anxiety, let's move over to TypeScript and see how we can fix everything. Okay, let's shift things over and start using TypeScript for this project and see what TypeScript is going to be able to offer us immediately out of the box. In Scrimba, the way TypeScript is running under the hood is a little bit different than if you were following along on your local machine. Normally, I would be able to just change my JavaScript file to a .ts file extension and set TypeScript up as a dependency of my app. But with TypeScript running in the background on Scrimba, I need to make sure that I actually create a brand new file called index.ts. We'll talk a little bit more about setting up TypeScript in a local environment, so this isn't a big deal that we have to worry too much about now, but another Scrimba specific thing, I need to change this to .ts, and we'll go ahead and copy all of our code over from JS to TS, and look at that, we get a bunch of red squigglies. Of course, JavaScript was perfectly happy to let us write the code that we had before, but out of the box, TypeScript is able to warn us ahead of time of any potential errors that we might have. Now, I want to reiterate that throughout this course, anytime you see these red squigglies, I want you to actively move your mouse, hover over the word that has the red squiggly, and see the IntelliSense pop-up that shows up. I can see it on my end, but it's not something that Scrimba records into the scrim. So very often I'll be saying, if you hover your mouse over this item and look at the pop-up, I actually want you to do that. In fact, I want you to do that. Pause now, start hovering over some of the red squiggly words that you see here, see if there's any bugs that you can fix right off the bat. Well, some of these are giving us errors about the variable implicitly having an any type. That's something we're going to talk about in the future, but if you came down here to cache in register, you can see that it says you cannot assign to cache in register because it is a constant or a read-only property. And assuming at this point you know the difference between a const and a let, that should be a pretty obvious fix. Maybe out of habit, I initialize this as a const, but I'm trying to assign a new value to it in the future, and I can't do that with a const. So let's go ahead and change this to a let, and by making that very simple change, TypeScript is now satisfied when it comes to this cache and register variable. Let's come here to next order ID, and we have the exact same problem. This needs to be a let instead of a const. By doing that, now TypeScript is satisfied about next order ID. At first glance, using TypeScript can be a bit intimidating because of all of these red squigglies that show up, and because of the additional code that you will have to write to fix the errors that it's warning you about. But I think a better approach or a better lens to look at this through is that TypeScript is showing us the problems in our code. Nothing about using TypeScript here is introducing new bugs, it's just showing me where the bugs already existed. This means I can find them immediately as I'm typing my code instead of having to wait till it crashes for our users. So over the next few scrims, we're going to fix the bugs that are already here. We'll be adding new features to our app and seeing where TypeScript is and isn't happy, all while using that to drive forward our knowledge of TypeScript. There's one more error in here that we're able to fix before we even start writing TypeScript-specific code, and that's here on line 18. Go ahead and hover your mouse over selected pizza here, and you'll see the pop-up says the object is possibly undefined. This is a great example of a time where TypeScript is able to warn us ahead of time that we have a potential problem. And this brings me to a point that I will likely reiterate in the future in this course, and that's the difference between coding on the happy path and the sad path. Now, the happy path is when we are writing our code and we just assume that everything is going to work out perfectly. This does tend to be the code that people who are new to coding will write. I would say mostly because they haven't been hurt in the past by code pushed to production that didn't account for the edge cases that can pop up when you run code in production. And that's because this is the easiest code to write. We have a task that we're trying to solve, we write the code that solves that task, and then the temptation sometimes is just to move on. However, TypeScript forces us to take a step back and consider the sad path. The sad path is when we account for or assume that problems may occur. It forces us to think of those edge cases where problems can arise and address them in our code the first time before we have complaints from our users in the live production version of our code telling us that the code is crashing their browsers. In a way, you can think of this as being a more defensive way to write your code. And truly, it's not as easy. You really have to think about all of the edge cases that can occur when your code is running in a live environment. And it can be difficult to imagine the sometimes weird ways that our users might use our code in unexpected ways. Now, TypeScript is not perfect for this, but it makes writing for the sad path significantly easier. And a perfect example here is with selected pizza, when it tells us that this object is possibly undefined. And I'm sure that you've run into the error that happens when you try to access a property of undefined. You'll see something like cannot access property price of undefined. What's happening and what TypeScript can foresee being a potential issue is that we're trying to find an item in our menu array based on the pizza name string, and TypeScript can see that it's possible this may come back as undefined. If we're searching for a pizza that maybe we misspell or is some nonsense pizza that doesn't exist inside of our menu, then selected pizza is going to be undefined, and TypeScript says that would crash your program. To satisfy TypeScript in this case, we can code a bit more defensively and say if there is no selected pizza, then first let's go ahead and run a console.error. We'll maybe say something simple like the current pizza name that you're trying to search for does not exist in the menu. Then, to satisfy TypeScript, we need to return from this function, or alternatively, we could throw an error. But the point is we want to stop execution of this function, and by adding this return in here, now TypeScript knows that this line of code will never get reached if selected pizza is some falsy value like undefined. I guess I could be a little bit more specific and say something like if selected pizza is equal to undefined. Notice that that also satisfies TypeScript in this case. I'll go ahead and just leave it as a check for the falsy value. Okay, now it does feel a bit ridiculous that we haven't actually run our code yet. The reason is because I knew there was a bunch of errors in here that we had to start fixing. But now it's time for us to finally run our code, and we can see that we do get a type error that says cannot set properties of undefined. I thought this is what we just fixed. This one, though, is talking about setting the status property. Now, where is that happening? That is happening where we complete the order.status. Now there's a few points to be made here. First of all, it might seem strange that TypeScript is not warning us that order is potentially undefined in the same way that it was warning us that with selected pizza. There actually is a reason for this. We're going to address it a little bit later on. But secondly, and I'm sure this was driving a bunch of people crazy, when I'm calling complete order, I'm passing in a string ID instead of a number ID. And TypeScript isn't warning me about this. At this point in this particular program, we've reached the limit where TypeScript is able to help us without us going out of our way to write TypeScript-specific code. It's really nice that we were able to fix a couple bugs, and we can see that there are potential other bugs simply by including TypeScript in our project and using a .ts extension on our file instead. But since we've reached that limit where TypeScript is no longer willing to help us without defining specific types in our program, let's finally jump in and start learning some TypeScript-specific code, starting from the basics. We're starting to see some of the benefits of using TypeScript, but I think they will really start to sink in as we're building a real project. In order for us to do that, we have to learn some of the very basics of TypeScript, and that is how to type a variable. When I'm writing vanilla JavaScript, I can say something like, let my name equal Bob. And because TypeScript is a superset of JavaScript, any JavaScript code that we have will be legitimate TypeScript code. Now, perhaps unconventionally, I'm going to start this lesson by saying, when you write a line of code like this, TypeScript is very smart and it's able to infer what data type is being used for the variable that you just created. So go ahead and hover your mouse over this variable, my name, let it sit there for just a second, and you'll see a really small pop-up that says, let my name, string. Here, what TypeScript has done is it has inferred or derived what data type my name is supposed to be. Now, while we are about to learn how we can manually provide different data types to our variables, I do think it's important to note that the work that we're about to do is busy work. It's not something that TypeScript requires you to do because it's able to figure out the data types simply by the data type that you assign to it. To demonstrate that, if I then try to say my name equals a number, we get a red squiggly, and if you hover your mouse over my name, we'll see that it says the type of 5 is not assignable to the type of string. In other words, TypeScript is angry that we're trying to reassign a number value to a variable that was originally set to be a string. As a side note, sometimes people talk about JavaScript's dynamic typing nature, where in regular JavaScript, this operation is not a problem at all. They talk about it being a strength in the flexibility of JavaScript, but in practice in the real world, off the top of my head, I can't think of a reason why this would be a beneficial feature for us to be able to reassign a string value to something that's a completely different data type. It's a code smell to me, which means that if I see something like this or I'm attempting to do this in my code, then I'm probably structuring my code in a bad way. So TypeScript forces us to think of better ways to organize our code. Anyway, let's get back to manual typing. Now, although TypeScript has correctly derived that this is going to be a string type, I can manually give a type by typing a colon immediately after my variable name and then typing out the lowercase version of what data type I want this to be. So this might look a little strange. This is one of those instances where the TypeScript syntax is different from JavaScript syntax. This would not be correct syntax in vanilla JavaScript, but it is something that you'll see all throughout TypeScript and you'll just get used to typing it. Now let's get our hands on the keyboard and do an admittedly really simple challenge. We've already used the primitive data type of string, lowercase s string, and in TypeScript the other two primitive data types that we'll use are number, lowercase n, and boolean with a lowercase b. The reason I'm creating a distinction between the uppercase and lowercase is because in JavaScript there is an uppercase s string constructor, an uppercase n number constructor, and the same with boolean. But that's not what we're accessing when we're doing these types. Okay, should be super easy. Pause now and work on the challenge of explicitly typing these variables below. Well, if we hover over number of wheels, again, we can see that TypeScript derived the data type of number. I guess this could be an easy way to cheat into knowing exactly what to be there, but this is so straightforward, I'm not concerned about that. We're going to add colon number and colon boolean in order to explicitly type these variables. Okay, there's a little bit more syntax that we're going to learn when it comes to manually providing some types. So once you feel pretty good about what we've done here, let's keep moving forward. We'll be talking about typing inside of functions really soon, but I thought it would be a good chance to apply what we've learned to our pizza restaurant app. So your challenge is to teach TypeScript what data type should be used for the orderId parameter here in our complete order function. Then once you've added that, keep a close eye on the rest of the program to see if TypeScript has any new warnings. And if something pops up, go ahead and fix that. Pause now and work on this challenge. Again, this is a bit on the nose because we know that this is not supposed to be a string, but let's just assume that we missed that little error, and we'll say that this orderId is supposed to be of a number type. And sure enough, because we've gone out of our way to add just a few additional characters to our complete order function, TypeScript now knows that we're using this function incorrectly. We're passing in a string where it shouldn't be. If you hover your mouse over the 1, it says that the argument of type string 1 is not assignable to a parameter of type number. And great, yes, that should be a number. Let's go ahead and make that a number, and let's hit save. And look at that. There are other potential issues in our program, but because we're using TypeScript, we are no longer crashing with type errors. All right, now at this point, our app would benefit from us starting to write what's called custom types. So that's what we'll start learning in the next lesson. We've talked about a few primitive types like string, number, and boolean, but in TypeScript, we also can create our own custom types. At first, this isn't going to seem super useful, but just bear with me. We can create new types by using the type keyword. This is something that exists only in TypeScript. And by convention, the name that we give our type is going to start with a capital letter. For example, I could say type food is equal to string. By doing this, I now could use the capital F food as my way of providing a new type to this favorite food variable. Now, doing this with primitive types like strings, numbers, and booleans won't make a whole lot of sense until we talk later down the road about something called unions or intersections, but this can come in handy for creating custom types around objects. Let me show you what I mean. I have this person object with 3 properties, name, age, and is student. A pretty common thing with objects is that you might have multiple of the same kind of object. So let's say we have a person2, which looks very similar. We're going to have Jill, age 66, and we'll go ahead and say is student is false. As it stands, there's no problem with this code. However, you might have noticed that I used a lowercase in this isStudent property and an uppercase s in this one. One of the benefits of using TypeScript is that it forces us to stay consistent, and although this may not cause a bug the way it's written currently, it seems pretty ripe for a bug down the road. What we can do is create a custom type of an object that defines the shape of the object where we can give it exactly what the property names are. I can create my custom type by using the type keyword. I'll use capital P person as my type, and I'll set it equal to an object. And what I'm doing inside of this object type is telling it what properties it will have, like name, but then instead of providing a value, I'm going to give it a type. I want my name to be a string type. One quick side note about custom object types. In a regular JavaScript object, it's syntactically correct to have a comma to separate each one of your property names. However, when you're creating an object type like this, you can use commas. You also can use semicolons. You also can just leave them out. So for me personally, I'm probably going to just leave out anything at the end here, but you can choose whatever you want. And it's most important just to stay consistent within the project that you're working in. Okay, just so we can avoid some passive listening here, I'm going to include a really simple challenge here. I know it's a little bit of busy work, but getting your hands on the keyboard is always a win when you're learning to code. So your challenge is to finish the object type definition. So let's say so that it looks like person, and you know what, let's call this person1, so that this type is the same shape as person1. Pause now and work on the challenge. Okay, well, we're going to put age is a number and is student is a boolean. Simple enough. Now, let's take a step back. Obviously, writing this out has cost us more work. It's used up 5 more lines of code. Frankly, it doesn't take very long, but it can feel like it's breaking your flow. However, by doing this, we've added an extra degree of type safety. When I'm defining person1, I can use my colon and set it equal to my custom type, person, and I can do the same thing for person2. We'll say this is capital P person, and check it out. Even though we had to go out of our way to define this custom object type, by doing that little extra work, we have already been able to identify a potential problem. We know that these 2 objects should be the same, but we might have just missed it because we're fallible humans. Let's put in a capital S and satisfy TypeScript. Spend some time playing with this code, and when you're ready, we'll move on and talk really briefly about nested object types. Let's set a standard in our pizza restaurant app as to the shape our pizza objects should have, and I'll have you do that through a challenge. Your task is to create a pizza object type. It should include a name and a price property, and that'll be the extent of the challenge for now. We'll apply that in just a minute. So pause now and work on this challenge. Okay, this should be pretty straightforward. We'll say we have a new object type called pizza, and it needs to have a string name and a price, which is a number. Okay, easy enough. Now what I want you to do is to pause, look through our code, and see if there's anything obvious that you can enhance with TypeScript by telling it that the type should be of this pizza object type. So pause now, peruse through the code, experiment a little bit, see what happens, and then I'll have an official challenge for you. Well, if you're anything like me, you probably went through and started looking at the different red squigglies that we have. And right here in our add new pizza, we have this pizza object, which if you hover over it, TypeScript warns us that it implicitly has an anytype. That term anytype isn't necessarily supposed to make any sense to you yet, so don't worry about that. We will be covering that soon. But this brings us to the next challenge. All right, your challenge is to teach TypeScript that this pizza object in this add new pizza function is supposed to be of type pizza. Then, like before, once you've done that, look through the code and see if there are any new warnings you need to deal with. Of course, there are going to be, and fix those issues. Pause now and work on this challenge. All we have to do is put a colon and then a capital P pizza after this. TypeScript is no longer warning us that pizza object is implicitly an anytype, and in fact, if you hover your mouse over pizza object here, it will specifically tell you it's a parameter and it's of type capital P pizza. All right, let me clean up this text and we'll just go ahead and peruse down here in our code and check it out. Down here, when we were adding a new pizza, we have these 3 new errors over cost. If you didn't have a chance to do this already, hover your mouse over cost, and you'll see that it tells you that the argument of type nameString cost number is not assignable to the parameter of type pizza. Okay, well, that's interesting. The next thing it says is that the object literal may only specify known properties, and cost does not exist in type pizza. And sure enough, when we wrote this, we might have forgotten that it actually is supposed to be price, not cost. TypeScript saving us again. We can go ahead and change these to price instead of cost and hit save. And sure enough, everything is working as we'd expect. Now, I assume a number of you were probably screaming at me this whole time when I first wrote cost here in the beginning. I promise it was all planned out and staged. But notice that without writing our pizza type and specifically telling add new pizza is supposed to be taking a pizza object, that our program wasn't necessarily crashing. If you looked at our menu before, we had an array of the items that we initialized in the beginning, but then we also had added items with a name and a cost property. And I don't know about you, but that makes me feel gross to know that we have these mixed types in our menu. That's just asking for crashing bugs down the road. By adding just a few lines of really simple TypeScript, we were able to defend against that problem that not only would never have shown up in regular JavaScript, but also wasn't even showing up as issues here in TypeScript until we went out of our way to create this pizza type. Okay, we're making good progress on fixing up the bugs in this app. Before we move forward, there's one really easy update that we can make, and it's so easy I'm not even going to make it a challenge. Here in our place order function, if we hover over pizza name, which TypeScript is warning us about, it says that it implicitly has an anytype. Let's go ahead and type that as a string and get rid of that warning. Great. Well, it looks like the majority of the issues, actually all of the issues that we have left, have to do with this variable orderQueue. So let's go ahead and tackle this issue next. Let's say we want to build out our person object a little bit more, and we want to include an address property. Well, typically something like an address wouldn't simply be represented by a string, but instead by a nested object. The most straightforward way to do this is to simply type it out as if I were typing out a regular object. I can put my curly braces there, and just like I did with the rest of my type, I can say maybe there's a street portion of my address, and this is going to be a string. We'll just stick to street, city, which is a string, and then we'll also say, let's do country, and that'll also be a string. Okay, what do you notice about our code now? Well, our objects below are typed as person objects, or person types, but we just changed the definition for person to say that it must include an address. If we hover over the red squiggly, which you should also do right now as you're watching this, it tells us that the type of this person1 with the object as it currently stands is not assignable to the type of person. In other words, there's a mismatch between the derived type of this variable that we've just set, which TypeScript can see is a name with a string, an age with the number, and a isStudent with a boolean, and it sees that that doesn't accurately match the person type that we just redefined with the address property. Assuming we do actually want every one of our objects to have an address property, we would need to make sure that we update our objects to include an address property that includes all of the subproperties of the person type definition under address. So that means I would have to have a street. Let's just put something generic in here. A city, we'll say this is any town, and the country we'll say is USA. I'm sure you noticed as soon as I added country to my address, it then satisfied the definition for this person type, and TypeScript stopped complaining. Removing any one of these properties is going to make TypeScript complain because it doesn't perfectly match the type that was up there. Now, I can guess what some of you might be thinking at this point, because this is exactly what I thought at this point in my learning of TypeScript, is that TypeScript feels so extremely rigid. We've become very accustomed to writing JavaScript where essentially anything goes, and we fix the bugs that we have while we're testing out our app, and we kind of hope that we fix it all, but at least we get some freedom and flexibility. I have two things to say to that. First of all, we are going to learn a way in which we can make these properties optional so that TypeScript won't scream at us if, for example, we don't want person 1 to have an address. But secondly, I would say that you should work really hard to force yourself to become comfortable with that extra rigidity that's offered by TypeScript. At first, you might think that it's sort of stealing the fun of slinging JavaScript code and building projects on the fly really quickly. However, when you're working in a real production environment at a company, you're going to find it less fun when you have to fix bugs in production because you didn't have the extra rigidity and type safety that comes by using TypeScript. All right, I'll get off my high horse now. One last thing before we move on, another common way that you will see this nested object structured is by not necessarily defining the types right here in line with our person object, but instead simply creating a separate type for the address alone. And so I'm going to turn this into a challenge. Your challenge is to try and figure out how to move the nested address object that we have here into its own type, like we see here. And once you've done this correctly, there should be no red errors in the editor below. I do want to point out that I haven't explicitly taught how to do this. What I'm trying to accomplish here is getting your brain thinking, get your hands on the keyboard, and see if you can put 2 and 2 together to figure out exactly what this would look like. If you're feeling stuck, rather than just hitting play and moving forward, I would recommend searching on Google or opening ChatGPT and formulating your question specifically so that you can be engaging your mind and really going out of your way to try and learn these things. When you just push forward and watch me do it, it doesn't sink in quite the same way as when you are more engaged. Okay, getting off my soapbox now. Pause now and work on this challenge. Well, I should be able to just take the properties of my address here. I'll cut those out. I'll put them into their own address type up here. And then instead of doing an inline object here, I can simply refer to the capital A address type that we defined above. And after I've done that, you can see there are no more errors in the editor. Either of the two ways that we just saw it is completely fine. If you think that you are going to be using this address type elsewhere in your code as a standalone type, then it makes sense to separate it into its own address type like we just did. Or if you already know that address is only ever going to exist as an object in the context of a person object, then you can just leave it nested inside of the person object and that will work just fine as well. Once you've had enough time to play around with this and feel pretty comfortable with it, then you'll be ready to move on to the next scrim where we will talk about how we can make some of these properties optional if we need to. Something that might put your mind at ease regarding TypeScript rigidity is knowing that when you're creating object types like we see here with person, you can define some of these properties to be optional. Now, this comes with a caveat. When you're making decisions about whether something should be optional, TypeScript comes with a number of ways that you can relax that rigid nature, but you should learn to force yourself to really ask the question, do I really need this to be flexible? We're going to see multiple different ways in which TypeScript offers that flexibility. However, they always come with the trade-off of reduced type safety. Let's get the syntax out of the way for doing this because it's really simple. For example, if I don't necessarily want every person to have an address, you can see removing address gives me some TypeScript warnings. When I'm defining my type, I can simply put a question mark after the property name that's going to be optional. You can see as soon as I typed that question mark, the warning under person 1 went away. And that's because now the address property is optional. This has offered me a bit of flexibility. However, as I mentioned, it does reduce my type safety. We'll be talking more about adding type safety to functions soon, but let's say I have a function that's called displayInfo, and this function is going to take a person as a parameter, and in it, it's going to console log, and let me use a template string here. We'll say person.name lives at, and then we'll stick in person.address.street. Okay, so now later in my code, or maybe in another module, I import displayInfo, and I'm going to call displayInfo and pass person1 to it. Well, this is a bit on the nose. I'm sure that you can see what this problem is going to be. Let's hit save, check our console, and sure enough, cannot read properties of undefined, that dreaded error that we see. Notice that it says it's a type error. This is an error that was introduced, well, really for two reasons. One, because we chose to make this an optional property, but in truth, maybe more importantly, because we didn't add any type safety to our function. I can technically get rid of this error by using optional chaining right here on address. One thing to note is that currently Scrimba doesn't understand optional chaining, but trust me, this is going to work just fine. However, this solution isn't great because if I hit save, we see that we get Joe lives at undefined. Not a program crashing type error, but still not a great experience. Now, don't let me get in your head too much. Adding an optional property is a completely legitimate and fairly common thing to do in TypeScript. I'm just making sure I do my due diligence in letting you know that every time you add one of these sort of flexibility enhancing features of TypeScript, you are going to reduce your type safety by a little bit. Okay, let's move on and apply what we've learned to our pizza restaurant app. Okay, let's jump right in with the challenge. Your task is to create a new order type. In that type, it should have an ID, pizza, and status properties. I won't explicitly give you what data type those should be, but just look through the code if you need some hints as to what it will be. Pause now and work on the challenge. Okay, let's create a new type called order. And this will be an object. It's going to have an ID, which is going to be a number. Remember, down here we have our order numbers that we're keeping track of, and so that will be a number. The pizza property is going to be a pizza type, which makes sense because it's a nested object inside there. And the status property, for now, is just going to be a string. We're going to talk about this a little bit later. Let's clean up the challenge text, and hopefully that was pretty straightforward. Now, this wasn't explicitly part of the challenge. There's a chance that you came to the orderQueue and decided to try and make this of type order, and you'll notice that that doesn't fix the warning that TypeScript is giving us. And that's because the orderQueue is an array. It's not a single object. So before we can fix this, we need to learn about typing arrays. It's fairly straightforward, so we'll do that in a quick scrim after this, and then we'll come back to our pizza restaurant and fix these issues. We've learned about how to manually type the primitive types in TypeScript. For example, if you have something like let age equal 100, you can manually tell TypeScript that age is going to be a number like this. And there's a similar syntax when we are typing arrays. So if I have an array, and maybe we'll just call this ages so that it makes a little more sense, maybe 100 and 101, notice that TypeScript is complaining about the type of ages. Hover your mouse over the variable ages here, and you'll see that it says the type number square brackets is not assignable to type number. Well, it kind of gives away the syntax for typing arrays. All we have to do is simply put a set of square brackets as if this were the array syntax with an empty array right after the type. And this is how we teach TypeScript that ages should always be an array that consists only of number elements. If we were to try and put another thing in here, maybe the string 1, then we get an error again. It tells us that there's a problem with this last element because it is not a number inside of this array. The same will happen if I try to push something to the array that isn't of the correct data type, like ages.pushTrue. The red squiggly shows up here under true, and it says that it's not assignable to the parameter of type number. This should all be pretty straightforward for you at this point. I think it's important to note that in the same way that TypeScript is able to infer a regular number, TypeScript is also able to infer the data type of an array of numbers. So when it's an array with some simple primitive data types in there, we don't have to manually put colon, number, square brackets, or string square brackets, or anything like that. We can just let TypeScript do its job, and we're going to get the same benefits in the end. However, when we have a custom data type, like a person data type that we've seen before, let me fill this out again. We have a name string. We'll say an age is a number and is student is a Boolean. When we want to create an array of these people objects, well, actually, I think you'll be able to figure this one out. Let's make it a challenge. Okay, I took away some of the busy work here for you by creating a couple of person objects. I've already typed them as a type person, and your challenge, simply enough, is to create an array with person1 and person2 in it, and then to manually type this array as an array of person types. Pause now and work on the challenge. Okay, let's go ahead and set this equal to an array. We will stick person1 and person2 in there. And before I manually type this as an array of person types, I'm going to hover over this variable people, and you should do this as well. And you'll notice the pop-up does correctly type this as a person array. Because every item in this array conforms to the person type, it knows that this people array should continue to be an array of person type. But that's not what the challenge says. The challenge says to manually do it, so we'll put colon, person, and then the array bracket syntax. Now, normally, as I've said, it's good to let TypeScript do as much inference as it can, especially when it comes to primitive types like numbers and booleans. However, I'm a little bit more torn here. Yes, TypeScript is able to infer that people is an array of person types. However, adding it here explicitly does make it a little bit easier for myself or other developers to read in the future. So in this case, I'm just going to leave this here. We also can note that if I don't manually type it and then I remove the person type declarations here and hover over let people, we can see that now it has inferred the type to be an object literal with all of the properties instead of having the person type as an array here. But we're using TypeScript. I can't think of a good reason to not type these as person objects, so we'll just leave it like that. And maybe I'll go ahead and put back my colon person array as well. Really quickly, there is another syntax which you may see floating around, and we will talk a little bit more about it later in this course when we talk about the concept of generics. But for now, it's enough to know that there is a syntax where you can use capital A array, a set of angle brackets, and then put your type inside of the angle brackets. And I could use this in place of my person with square brackets, just like this. This is going to do the exact same thing. You can hover over people and see that it is correctly knowing that it's an array of person types. So I'm just covering my bases here. Don't worry too much about that. We're going to stick with this syntax for now and talk more about that other syntax when we talk about generics. Okay, let's get back to our pizza restaurant and apply what we've learned to our code over there. Here we are back in our pizza restaurant, and your challenge is to fix the TypeScript warnings that we have throughout our code about orderQueue. Pause now and work on this challenge. Okay, well, we already have our order type that we wrote previously, and we know that the orderQueue should always be an array of order objects. So by doing that, TypeScript is no longer complaining about orderQueue, and if we come down, we only have one more TypeScript warning here, and this is awesome. This is actually a really helpful warning, but everything else has resolved itself. Now that TypeScript knows that orderQueue should be an array of orders, it's able to ensure that we won't have any type errors in our program because we've generally written everything okay. Now there is this one new warning here under order.status. Order says that it's an object that is possibly undefined. And this should look familiar. This is exactly the warning we were getting above when we were writing selectedPizza.price. It was telling us that selected pizza is possibly undefined. So that brings us to the next challenge. Okay, now your challenge is to fix this warning below by handling the sad path scenario. Notice I'm being a little bit vague here. I do want this to be a chance for you to engage your brain, try to remember what we've learned before, look through the rest of the code. That should help you out quite a bit. Pause now and work on this challenge. When we're running orderQueue.find, if we provide an order ID that does not exist in the order queue, then this order is going to be an undefined value. In fact, if you hover over order here, you'll see the IntelliSense pop-up. It says const order, colon, capital O order, and then a pipe character or a line, and then undefined. Similar to JavaScript with the double pipe operator indicating an OR logical operator, I like to read this single pipe in TypeScript like the word OR as well. In other words, const order is either going to be a capital O order object, or it will be undefined. And that's because TypeScript knows if it's not able to find something with the .find method, it will return undefined. And in this case, we're not handling that in our code. TypeScript saves us again. So if there is no order, then maybe we'll just do what we did above, where we console error, let's say orderId was not found in the order queue. And then we'll go ahead and return, although as I mentioned before, this could be an opportunity for us to throw an error. If we were to throw a new error and then maybe put this message in there, that would work just as well because it halts the execution of this function, and therefore TypeScript is now satisfied that order.status is never going to get reached if order is non-existent. But just to stay consistent, I'll go ahead and keep my return here. Clean up the challenge text, and look at that! All the TypeScript warnings in our app are gone. Now, I do think it's important to note that the lack of TypeScript warnings doesn't automatically mean that our program will function exactly as we expect. It doesn't mean that we've handled every edge case, but it does mean with relatively little amount of effort, we have a much greater degree of confidence that our app is going to work as we would expect. Speaking of which, we haven't run this code in a while. Let's run it and open our console, and awesome, everything looks the way that we would expect. In order for us to touch on a few more topics in TypeScript, we are going to start building out new features in our pizza restaurant app. But before we do that, I do want to encourage you to get your hands on this code. Play around with this. Try adding some new functions or making some kind of change. It doesn't even have to be significant. For example, when I was first writing this, I decided I actually wanted to rename this to orderHistory. And if I do that, suddenly we get some errors immediately showing up in our TypeScript that are super helpful. They help us know exactly what needs to change. In fact, I'm going to leave this as orderHistory so that I can bug some of you into fixing this error and getting your hands on the code. Once you feel pretty comfortable with everything that we've written so far, let's keep moving forward. Hopefully you've had a chance to play around with the IntelliSense pop-ups that happen when you hover over different variables that you declare with TypeScript. And something you might have noticed is the difference between how TypeScript infers different types. For example, if I were to say, let my name equal the string Bob, go ahead and hover your mouse over my name. Okay, you'll see that it says, let my name : string. So TypeScript has correctly inferred that my name is of type string, and it will warn me if I were to ever try and change it to a different data type. You can see here TypeScript is saying that you can't assign the value true to a string type variable. Okay, let's see how that differs, however, when we use const to declare our variables. So if I say const my name equals Bob, and I need a different variable name, let's say my name 2, because I'm really original right now, hover your mouse over my name 2. This time the pop-up doesn't show the type as a string, but instead it shows the type as the string Bob. This is called a literal type, and it's when you tell TypeScript that the type isn't a generic string, which would allow that variable to become any string, but instead it's a literal type, an actual value type of the string Bob with a capital B at the beginning. If you put a little bit of thought into it, then this will make sense, because with let, I am allowed to change the value of this variable, and TypeScript logically restricts the data type of the value I'm allowed to change it to a string, and with const, I'm not allowed to reassign this value. And so it makes sense for TypeScript to say this value has to be the string Bob from here on out. I can't say my name 2 equals Bill. This not only makes sense in TypeScript, but also JavaScript. We would get warned in regular JavaScript saying we can't reassign a const. And if you hover over my name 2 here, it says cannot assign my name 2 because it is a constant or a read-only property. Just for the sake of completeness, I can manually type something to be a literal type. So I could say const my name 2 : the string Bob equals the string Bob. Of course, TypeScript already inferred this, but this is what that syntax would look like. I could do the same thing with my let. I could say let my name : the string Bob equals Bob. And if I were to try and change this to anything else, like Bobby, then I get a TypeScript warning. The same thing would happen down here. Now, there are times where you may see this being useful in TypeScript, but more often than not, the concept of using literal types is much more commonly found when you pair it with a concept called unions. So feel free to play around with this code, and in the next scrim, we'll learn about what unions are. As I mentioned, there certainly are going to be times when a literal type by itself can be useful. However, you will oftentimes see them being used combined with a concept called unions. Let's start with an example. Let's say we are working on an application and we want to maintain a different kind of user role. For the sake of our database and our application, we're going to be saving that user role either as guest or member or admin. And in our app, we don't want someone to be some kind of user role like a hacker or something completely gibberish that doesn't make sense to our application. In this kind of scenario, we can use a combination of literal types and this concept called unions to teach TypeScript that this variable user role should only be allowed to be one of a certain number of strings. If you're familiar with the concept of enums in other languages, this is essentially the same idea as an enum. There's a little bit more to be said about that because TypeScript does have something called enums, but let's not get bogged down by that topic for now. If you're not familiar with the concept of enums, well, you already are familiar with the concept of an enum because you know what a Boolean is. A Boolean can only either be true or false. It has to be one of those two values, and it can't be something like yes or no, at least not in JavaScript. So if we have our user role and we want this to only ever be guest, member, or admin, we can use union types in order to accomplish this. I'm going to create a new type called user role, and I'm going to set it equal to the literal value of guest, and then I can make a union by using the single pipe character. You can essentially read this just like you would the double pipe character in JavaScript as the English word or. So I can say that type user role is either going to be the string literal guest or the string literal member or the string literal admin. And now that I've defined what a user role type is allowed to be, I can tell my variable that it has to conform to the user role type. And from then on, if I were to ever change this to some gibberish, TypeScript would give me a warning. This literal union type that we have here doesn't just need to be its own standalone thing. I might have it nested inside of another type. So I might have a user type, which has all of the other properties that we might normally see, like a username of string, blah, blah, blah. And then I might say user role, or let's just call it role. And we can just copy what we have here and say that the user.role property has to be one of these three string literals. I won't necessarily go down and show an example because I think you get the idea. Let's go ahead and satisfy TypeScript by making this one of the available options inside of our user role union, and TypeScript is satisfied. Okay, let's jump back to our pizza restaurant app. There's a really small update that we can make now that we understand literal types and unions. We can add a little bit of extra type safety to our orders by teaching TypeScript that an order type is allowed to not just be any string, but it either has to be the string ordered or the string completed. This should be pretty straightforward. We'll make this a quick challenge. Go ahead and update our order type so that the status property can only ever be the string ordered or the string completed. Then once you've done that, try to make a change in our code. Maybe change the status to something other than ordered or completed. Some gibberish will do, and make sure that TypeScript is complaining about that change. Pause now and work on this challenge. Okay, we'll just make this so that it can't be any string, but it only can be the literal value ordered or the literal value completed. Now that we've made this change, we can actually see there's a new TypeScript warning, and that has to do with this line 35 where we have new order. This one can be a little bit confusing to understand, but let's walk through it step by step. Here we're creating a new order variable, and we're setting it equal to this object literal. When I hover over new order, we can see from the IntelliSense pop-up that it was able to infer essentially the shape of the object as having an ID that's a number, a pizza, which is an object with a name that's a string, and a price that's a number, and then a status that's a string. However, now that we have gotten more specific in what our order should look like up here where it has to be the string ordered or completed, not just any kind of string, the object that we're trying to push into our orderQueue, which if you remember we specified needs to be an array of orders, the data type that TypeScript inferred for our status right here is just a generic string. I know this can be a little bit confusing. Don't fret too much if none of that is making any sense. But the way that we can fix this error is by saying when we are instantiating a new order, we can tell TypeScript specifically this is going to be of an order type. By manually typing this as a type of order, it now knows that the status of ordered here is not just any old string, it is conforming to the status literal union type that we defined up here. And because of that, orderQueue, which needs to be an array of orders, is okay with us pushing in a new order. And if I were to try and change this to something like blah, 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 now TypeScript is complaining again because it knows that that's not okay. It can't just be any string. It has to be one of either ordered or completed. So let's go ahead and change this back. The same thing would happen if I come down here and I change this to blah, blah. Now TypeScript is not going to be happy with me updating order.status because it knows that blah, blah is not one of the legitimate statuses for our order object. As always, play around with this code, and once you're ready, we'll keep moving forward. As we've talked about, TypeScript is great at inferring primitive types and other more complex types that don't necessarily hold a lot of weight in the functionality of our app. However, there are certain times when we would really want to make sure we manually include the type of something. For example, here in our menu, we're defining the menu as an array of these objects, and these objects just so happen to conform to our type of pizza, but we haven't actually told TypeScript that our menu should be an array of pizza items. This becomes a lot more apparent when we try to make a definition change to our type of pizza. Let's say we were tasked with creating a new helper function called getPizzaDetail, which allows us to find one of the pizzas in the menu either by its ID or by its name. Well, currently we don't have IDs in our pizzas. And so we might think to come up to pizza and say, this should also have an ID that's a number. And doing this, because it's TypeScript, really helps us out further down the road when we find out some of our code is not going to work the way we think because they don't have IDs when we're trying to add new pizza and so forth. But I'm not concerned about this quite yet. We'll get to that later. But notice that our menu does not have a problem with the change that we made to our pizza type definition because it doesn't know that it's an array of pizzas. So let's go ahead and type it as an array of pizzas. Okay, now TypeScript is warning us. Hover your mouse over menu, and you'll see that it's complaining about how there's an ID property missing in these objects here. Great, that's a good warning. That just saved us some trouble. So I'm going to go ahead and add a manual ID property here, and we'll just kind of make them increment manually. Notice if we scroll down, we used to have an error, I think it was here on new order, because the pizza we were adding did not have an ID, and pizzas now need IDs. But we are correctly getting errors down here with add new pizza because these ones don't include IDs. For now, I'm just going to manually add IDs here as well. This is just a temporary fix until we figure something else out. What we just saw is a perfect example of how TypeScript doesn't make your job harder as a developer, and it actually significantly improves your ability to add new features and to debug your code in the process. All I had to do was make an update to my pizza type, and TypeScript immediately showed me where all of the problems with that change would happen. And I was able to pretty quickly go in and fix them. Granted, the fix will not always be quite this easy, but hopefully you're seeing the benefits nonetheless. Next, we'll move on to a concept called type narrowing, and we'll do that through a series of challenges. To start us off on a lesson about type narrowing, I'm going to give you a challenge. I want you to create a new utility function called getPizzaDetail. It's going to take a single parameter called identifier, but there's a little twist to this. We want to allow this identifier either to be the string name of the pizza, like the string pepperoni, or it could be the ID number of the pizza, for example, the pizza with the ID of the number 2. You don't have to worry about the code inside of the function just yet. I just want you to create the function signature and just make sure that you type the identifier parameter correctly so that TypeScript is okay with it either being a string or a number type. I haven't taught how to very specifically do this one thing, but assuming you've been following along and doing the challenges, I think you'll be able to put this one together. Pause now and work on this challenge. Okay, let's create a function called getPizzaDetail. It's going to take identifier as a parameter, and we're going to type this identifier as either a string or a number. And this is what I meant by saying we haven't specifically taught this thing. We talked about doing it with string literals if we wanted it to literally be one value or another value, but we can also use unions with more generic types like you see here. Okay, let's start working on the internals of this function. And really what I mean is I want you to do this. I'll make this into a challenge. I'm getting a little bit more vague with the details of how to accomplish this challenge, but that's okay because I know you're up to the task. I want you to write the code for our getPizzaDetail function so that it's able to use the identifier, whether it's a string or a number, and use the menu.find method accordingly. Once one of the pizzas from the menu has been found, it should return that pizza. For now, you can just assume that it will find something in menu.find. You don't have to handle the instance where it might not find something. Pause now and work on this challenge. Okay, let's get started on this. In JavaScript, we can determine what kind of data type identifier has by using the typeOf keyword. And so I'll use an if statement that says if the type of identifier is a string, then I can assume that it's going to be the name of the pizza, and so I will return whatever comes back from menu.find, and we'll say for every pizza that we're looking through, if pizza.name is equal to the identifier, then it will find the correct pizza and return it. One little feature I think I'm going to add is I'm going to lowercase both of these just so that if they put in the wrong capitalization for the pizza name or something like that, then it will still be able to find the correct pizza. Now, for the next part, I'm going to just use an else instead of an else if checking the type of the identifier to be a number, but I'm doing this specifically so that I can show a limitation of being less specific. For now, we'll essentially return this exact same line, except instead of .name, we're going to check the ID. And we don't need a to lowercase because that's going to be a number. And actually, check this out. If we hover over to lowercase, TypeScript is able to tell us that to lowercase does not exist on type number. This is super interesting because it highlights the fact that TypeScript is able to parse and understand our code, and it knows that we have already handled the instance where the identifier might be a string. And because we've told TypeScript that the identifier is either a string or a number, it knows that in this case, according to what we have told TypeScript the type of the identifier will be, in this else statement, it has been able to narrow the type down to be a number. Also, if we were to have copied this line of code down and simply removed the to lowercase, but forgot to change this from name to ID, TypeScript warns us that we can't use the triple equals to compare a string, which it knows pizza.name is, and a number, which now that we have narrowed the type down, we know that it is no longer going to be a string if it's reaching this code, and so it's able to warn us that these things aren't going to equate correctly. So just another instance of TypeScript helping us out. So this is just one example of this concept called type narrowing, where when we're writing a function and we don't necessarily know what the data type of that function is, TypeScript will expect us to narrow down the type and handle each use case, or potentially provide a default for all other use cases if it isn't in the if or else if statements. Soon we're going to see another example of where type narrowing is really important. But first, I want to address this else statement that we have, as I mentioned I would. We'll do that in the next scrim. Although this isn't a specific benefit created by using TypeScript, one thing that writing your projects in TypeScript will help you do is remember to be as explicit as you can when you're writing your code. For example, I have told TypeScript that my identifier is either going to be a string or a number, and I've handled the case where the type is going to be a string, and therefore TypeScript can assume that inside of my else clause here, the type will be a number. However, in some instances, you may be working in a project where the code you're writing will end up being used in a plain JavaScript file, and the protection that other file would normally get if it were using TypeScript won't exist. So I've added this export in front of our function, and I'm going to use this index.js file to import our getPizzaDetail function from our index.ts file. And I can show that this is working, so I can say getPizzaDetail with the ID of 1, and we'll console log the result. And sure enough, we get our margarita pizza with the ID of 1. However, nothing is stopping this JavaScript file from doing something weird, like saying getPizzaDetail false. Because it's JavaScript, we're not going to get any compile time warnings here, and so I can run the code and get the value of undefined, which in all honesty, our function is pretty okay with returning anyway. But we could get a little bit better of a user, or I guess not a user, but another developer's experience can be improved if we're just a little bit more explicit here and we say something like, if the type of identifier is equal to a number, then we can run this code, and then we could include another else that maybe throws a new type error that says the parameter identifier must be either a string or a number. Okay, so let's hit save. And now by trying to use false in getPizzaDetail, we get our type error thrown so that the developer using a JavaScript file can get a little bit more of an intentional feedback loop. So long story short, when you're writing your TypeScript code, try to be as explicit as you can, within reason. Staying on the theme of being explicit with your TypeScript code whenever you can, I want to talk about function return types. Before we jump into that though, I did want to note that we previously talked about composing together different object types, but here we can see we have this type user, and for the role property of that user object, we're using the user role type that we created up above. So we can compose types together however we want. It doesn't just have to be when we're talking about nested objects like we saw at the beginning of the course. Okay, so here we have a users array, and we have a function called fetchUserDetails, which takes a parameter of username and sends back the user in its return value. Go ahead and hover your mouse over the name of this function, fetchUserDetails, and you'll see that in the pop-up it says function fetchUserDetails, parentheses, username : string, exactly what we have in the beginning of our function here in our code. But then it says : capital U user. The colon that we put after the arguments of our function gives us a chance to specify what type of data should be returned from our function. Now, TypeScript was able to infer that. As we see, it put a : user there. But in a lot of instances, it can be really helpful to explicitly type what should be returned from your function. So I would put a : and this is between the arguments of my function and the opening curly brace, and then I would just put capital U user here to teach TypeScript that this function should always return a user object. So if it was able to infer that it's returning a user, why is it helpful to explicitly put a capital U user here? Well, one of the major reasons I think for doing this is that it helps whenever we're refactoring our code. If myself or some other developer were to find this function and say, I don't know why it's returning a user, it should be returning the user.username instead. Well, if they try to do that, then they will get a warning from TypeScript saying that it's trying to return a string instead of explicitly a user object. If I don't include this explicit type declaration, then TypeScript has no problem with me completely changing the return value of this function, which, assuming this function is used throughout my codebase, would likely cause some other problems. So this is an opportunity for us to be a little bit more explicit and to specify that we want this to be a user object that gets returned. And if someone is going to change the return value of this function, they would have to come up and explicitly change this to something like string, and this would be the .username, which theoretically would be a prompt to that other developer or myself in the future to then go throughout my codebase and make changes every time we're calling this fetchUserDetails function. Let's keep this returning a user for now. Okay, it's been a minute since we've had a challenge, so let's go back to the pizza restaurant app and try our hand at a quick challenge. We just talked about the TypeScript-specific type called void, and there are actually a few other TypeScript-specific types that I think would be worth taking a little tangent to talk about at this time. We'll start with a rather notorious type in TypeScript called any. The easiest way to think about any is to know that if you type something with any, you're essentially turning off TypeScript checking for that value. So if I have a value and let's set it equal to 1, TypeScript is able to infer that this should be of type number. You can hover your mouse over value to see that. And it gives me warnings if I ever try to do something like reassign it to a string. It tells me that you can't do that. Or if I try to run an operation on it like dot to uppercase, which only works for strings, it tells me that you can't run this method on a number. These warnings, of course, as we've seen up until now, are very useful to us. But let's see what happens if I manually type this as an any type. Suddenly, the warnings go away. As I mentioned, we've turned off TypeScript checking. So I can tell value that it's going to be a string now. I can try to call, say, an array method on it, and TypeScript isn't going to warn me at all. Essentially, it's a way to say in your code, I know better than TypeScript how this thing should be typed, and I don't want TypeScript to help me at all. I think you can probably see, maybe from my tone or just from the lack of warnings here, that this is not a good idea. So when really should you use any? Well, in short, you shouldn't. It can be tempting when you're looking at your code that has a bunch of TypeScript errors to just throw your hands in the air, type things manually as any so that the warnings go away, and then continue on with your code. But in that case, why did you choose TypeScript in the first place? Now, that's not entirely fair. I think there is at least one legitimate use case, and I think that would be if you're in the process of transitioning your code base from JavaScript to TypeScript, and you don't have the time right now to write all of the complex types and update all of your code to satisfy the TypeScript warnings, and you just need a temporary, that's the important part here, temporary way to get around TypeScript just for now. But be warned, as soon as you start adding any to your code base and the warnings go away, it might be a bit difficult to go back and force yourself to bring those warnings back by removing the any types. In fact, it might be better if you just left the warnings there and turned off the configuration in TypeScript that forces you to satisfy the TypeScript warnings before your code will compile. We're venturing into territory outside the scope of this course, so if there's just one thing I want you to take away from this lesson, just don't use any. If you do have a scenario where there's a value where you legitimately don't know the type of it, there's another TypeScript-specific type that is much better suited for that scenario, and it's called unknown. That's what we're going to be looking at next. Okay, we're going to do this in a couple parts. The first part of your challenge is to add a return type to the getPizzaDetail function. This should take you all of about 2 seconds to do. But once you do it, as it says in the note, you are very likely going to get a giant TypeScript warning, but don't worry about that. We're going to address that in part 2 of the challenge. Pause now and add a return type to our getPizzaDetail function. Simply enough, we can come between where the closing parenthesis is in our parameters and the opening curly brace. We can just put a colon and say that this is supposed to return a pizza. And look at that, we get those giant TypeScript warnings, and if we hover over it, it tells us that type pizza or undefined is not assignable to type pizza. Now, before I explain exactly what's going on here, I want you to think about it. Try and figure out why is it saying that the type pizza or undefined is not assignable to type pizza. In fact, if you want to pause to spend a little bit of time playing with the code or thinking about that, go ahead and do so now. We talked about this briefly when we first wrote this code, but remember that menu.find potentially returns an undefined value if it's not able to find the pizza that you specified. Let me get rid of my explicit declaration here, and for a kind of unrelated reason, I need to get rid of my challenge text. And now hover your mouse over getPizzaDetail, and you'll see that it did infer what data type would get returned from this function. It's either going to be pizza or undefined. TypeScript was smart enough to read through the code and know that we are returning potentially an undefined value, or rather a value of undefined inside of our code here. And so it inferred the return value as either pizza or undefined. This is where things can get a little bit hazy. You may want to rewrite your code a little bit differently to either throw an error if it wasn't able to find the pizza, or you can just expect that whatever code is calling getPizzaDetail will handle the instance where it gets an undefined value returned. But since this course isn't about how to architect this particular function, we'll go ahead and do another really simple challenge. Okay, again, really easy, but I want you to explicitly type the return value of this function so that TypeScript knows it could either be a pizza object or the value of undefined. Pause now and work on this challenge. Again, simply enough, we can just put a colon right here and say it's either going to be pizza or we will include the union of undefined. Like we saw before, this doesn't necessarily change the way that the function works or the way that TypeScript sees the function, but it does help us or other developers in the future know that when we're messing with this code and doing some kind of refactor, we need to either make sure that we continue to return a pizza or a value of undefined, or we need to explicitly change this value and then change our code everywhere else that's depending on getPizzaDetail either returning a pizza or undefined. Let's clean up the challenge text. All right, well, we're not quite done talking about return types with functions, so feel free to play with the code as always, and when you're ready, we'll keep moving forward. There's another return type that isn't quite as obvious as something like pizza or undefined was down here, and that is when you have a function that doesn't return anything. Look through the code on your screen here, see if you can find a function that doesn't currently return anything. Hopefully you found this add new pizza function. In fact, if you hover your mouse over it, you'll see that the inferred return type is called void. This function modifies the menu by pushing new objects to it, but then there's no return from it. There's not going to be a value that we can get from it. So one way we can be a bit more explicit, almost like documenting our code in line, is by explicitly typing this as returning void. It doesn't change the way that the function operates. If you try to save the return value from calling addNewPizza, you would get the value of undefined. But it helps us or other developers in the future reviewing through this code to know that we knew this wouldn't return anything. It's just performing an operation outside of itself and then not returning anything. That's about all there is for me to say about void. It's pretty straightforward. But since that was pretty quick, I want to give you a relatively unrelated challenge. Okay, your challenge is to add explicit return types to the rest of our functions. So really just the place order function and the complete order function. Pause now and work on this challenge. A really easy way to do this is for us to hover our mouse over the name of the function and see what TypeScript has already inferred is going to be the return type. Here we can see that it's either going to be an order type or undefined. And if we go to complete order, it's actually going to be the exact same thing, order or undefined. So really just getting our repetitions in with the muscle memory and typing these functions out. Okay, nice work. Let's move on. Let's take some time to do a really simple refactor to our code and see how TypeScript helps us do that. Currently, when we're creating the menu, we are manually adding our IDs here with 1, 2, 3, 4. And I brought the calls that we had down at the bottom up a little bit to add new pizza, and we were manually doing IDs of 5, 6, and 7. Let's go ahead and use the same trick that we're using with next orderId right here, where when we are creating an order, we are creating an object right here where we're using next orderId++. If you run into any TypeScript errors, make sure to hover your mouse over them and see if you can figure out how to fix them. As a little peek into the future, for now, we will still keep the IDs here inside of our add new pizza call, but my goal is to get us to a point where we can submit a partial pizza object without the ID and have the function handle adding the ID for us. But for now, we'll skip that part. Pause now and work on the challenge. So I might want to come here and say, let's call it next pizza ID, and we'll start it off at 1. And then up here, instead of 1, I can say next pizza ID++. And check it out, we're getting an error from TypeScript. You probably already know what this is, but if we hover over this, it says the block scoped variable next pizza ID is used before its declaration. Variable next pizza ID is used before being assigned. And yes, it is. Down here on line 22, we are defining that. And because of the way hoisting and everything happens in JavaScript, this would actually need to be above where we're using it. So let's just move all of these global variable declarations up here to the top, and then we should be fine. TypeScript is already helping us out. Okay, we'll do the same thing here and there. And down here, when we're adding new pizzas, we will go ahead and do the same thing. Down here at the bottom, I am still console logging the menu and then a couple other things that we actually don't care too much about right now. Okay, so I'm adding 3 new pizzas. Down below, I am still console logging the menu. We'll comment these other ones out for now. And let's open our console and hit save. And perfect, we have our menu with all 7 items in it. Now let's address this issue where it seems a little strange that we are providing a pizza object, but we are in charge of ensuring that the ID is being handled correctly. It seems like the add new pizza function should be able to handle that for us. So I want you to test that out. I'm going to write this in as a challenge. Okay, I'm calling this challenge part 1.5 because there's a topic in TypeScript we still have to learn in order to do this without TypeScript complaining at us. So as you'll see in the note, you're still going to run into TypeScript warnings that we are going to address soon, but the code should still run if you do it correctly. The goal is to make it so that we don't have to provide this ID property when we're adding a new pizza. We just have to provide the information that's specific to the pizza, and we can move the assigning of the next pizza ID inside of the add new pizza function as an implementation detail of this function. It's not really something that we should have to think about when we're adding a new pizza to our menu. We really only want to provide the details that are specific to the pizza. Okay, I think you should be ready. Pause now and work on this challenge. Okay, well, the pizza object that we are about to receive will be essentially the same as before, but without an ID. And so I'm going to, before I push it to the menu, we're going to say pizza object.id is equal to next pizza ID, and then we'll use the ++ trick to increment it to the next number so that the next time it runs, it's already changed. And then this is where TypeScript is going to yell at me. I'm going to get rid of these ID properties in the objects that I'm passing. And sure enough, TypeScript is screaming at me here. It says that I'm missing a property in the pizza object, and I'm typing this as a pizza object. But let's go ahead and hit save, and we'll open up our console. And sure enough, we get the same results that we had before. We have the 7 pizzas in our menu, and they have an incrementing ID just as we would expect. Okay, next let's address why TypeScript is screaming at us and how we can fix it. In this lesson, we're going to talk about something called utility types, but in order to set this up, I'm going to have just a really quick challenge for you. You can see here we have a user type. This is something we've seen before. We have an array of users that are typed as an array of users. And your task is to create this update user function. And what it should do is take a number ID as its first parameter. And the second parameter is an object that we're calling updates. And this object will not be a full user object. It's going to only contain the properties that you want to change. I've explicitly typed these as any just so that for now we can turn off TypeScript. And then we're going to learn about utility types so that we can type these the correct way. And actually, you know what? Just to follow my own advice, this should be typed as a number because that's not really what we're going to be talking about in utility types. Now, I've given you the instructions on how to do this. This is intended less to be about doing algorithmic thinking and more to just get your hands on the keyboard and make sure that you're staying active in this course. So you'll simply use the array.find method to get the correct one based on its ID. Then you'll use object.assign so that you can update the found user just right there in place. If you aren't familiar with object.assign or you're a little bit rusty on it, you can do a quick Google search to find how to use it. Okay, pause now and work on this challenge. Okay, let's go to, we'll say users.find, and this is going to return a user. We'll call it found user. And this will take a function, a callback function. We'll say for every user that we're looking through, we want to find the one that has the user ID that's equal to the ID that's passed in here in the update user function. Okay, we can move this comment up there. Let's go ahead and handle this scenario if there is no user. So if there's not a user, and this should be a found user. Let's just put something in the console. We'll say user not found, and then we'll make sure to return so the rest of the code can't run. Okay, and then we'll use object.assign. This will just change the object directly in place. This may or may not be the best way to handle it, but it's the most straightforward way. So we'll set the found user as the starting object, and then we'll replace any of the properties that are found in this updates object. We can get rid of this comment, and yeah, we're console logging users down here. Let's run this code. And let's see, we're specifically looking for the user with the ID of 1, and sure enough, the username is now New John Doe, and the last one with the username of Charlie Brown does have the role of contributor instead of member. Perfect. Okay, why are we talking about this? Well, obviously, as I've mentioned, we shouldn't be using the any type here. However, we're not able to use user as our type here because we're not providing a full user object. It's also important to know that because we don't know which property is going to be passed to this function, or potentially multiple properties, we can't come up and just create a new type like an updated user, because what exactly are we going to put here? We could say that it's going to be a username that's a string, but then what are we going to do if it's a role change instead? Well, you might be thinking, well, what if we just take every property from user and we make it optional? So we say, I don't know, maybe there's a way that we'd ever want to update an ID. We'll say, well, the ID could be a number, and we'll put the question mark here to say that that's an optional update. And we might have a username, so we'll set that as optional, and we'll say that's going to also be a string. And you know what? This is pretty much a lot of duplicated stuff, so I'll just go ahead, copy this one down, put a question mark there. Okay, great. Well, we've done quite a bit of extra work here. We would then be able to say this isn't going to be a user, it's going to be an updated user. Now we come down and we can see that TypeScript is no longer complaining. Not only that, but we run our code and things are working like they were before. Well, this was a lot of busy work. Imagine if we had a type that had 15 properties on it. That'll be a bit annoying to have to copy those over and just make everything optional. And at least as far as this code is concerned, we're only using this type in one place, right here for our update user function. So this is where the concept of built-in utility types comes from. In TypeScript, there are a number of types that, like a function, they can take other types in as a parameter, and they will return a new type that you can use with a few changes made to it. And these are things that are built directly into TypeScript. Their whole goal is to perform some commonly needed modifications to existing types so that you can continue to work within the TypeScript system. Kind of like we did here. Instead of creating updated user manually by copying all of the properties and then making them optional, we can use a utility type to accomplish this. We're going to talk about that in just a second. The other thing to know about utility types is that they use something called generic syntax, which uses angle brackets. Now, this is just touching the surface of that. We are going to talk about generics very soon. In our case here, with the update user function, we can use a built-in utility type called partial. And what the partial type does is it takes in the type that you pass to it. In our case, we want to make a modification to our user type that we built, and it returns a new type that has all of the properties set as optional. That should sound familiar because that's exactly what we just did manually. If you want to learn more about the partial type, click on the screenshot here. This will take you to the TypeScript documentation, specifically on the partial type. Okay, what does that look like? Well, instead of manually typing this out, I'm going to use the built-in type called partial. It's got a capital P, and I use that angle bracket syntax that we saw right here because this partial uses something called generics. Again, we're going to talk about that in the future, but you can kind of think of it like if partial were a function, you would normally put parentheses, but because it's a utility type and not a function, we use angle brackets instead. And we pass our user type in as a, you could call it a parameter, or in this case, it's really a generic type to this partial. And as we saw, what it does is it takes this user in and it returns a new type, which we're calling updated user. And if you go ahead and hover your mouse here over updated user, you will see that it has a type already defined for us where all of the properties, ID, username, and role, are set as optional. This way, when our update user function takes an updates object and its type is updated user, we can provide an object that is missing some of the properties from a user object. We've used this partial utility type to minimize some of the boilerplate code that we would have had to write manually ourselves. If you take the time to go over to the documentation by clicking this screenshot, you will see that there are a ton of built-in utility types in TypeScript. And so this might be a good time to click this if you didn't already. Just peruse those, play around with the code that you see here. Feel free to come up with different examples. We are going to talk about one other utility type because it's going to directly relate to what we're working on with the pizza restaurant app. But there is a small caveat that we'll need to work around. We'll talk about that in the next lesson. This lesson's going to be nearly identical to the one we had before, but as another way to drive forward the curriculum in learning a new utility type. To start off, to make sure your hands are on the keyboard and that you're awake as you're going through this course, I'm going to have you create the logic for a new add new user function. It's going to take a new user object, and in this case, the new user object will not have an ID provided to it. As you can see in the example usage down here, it will have all of the properties except for ID. So for now, I've typed this as any, and the return for this function needs to return an actual user object that does have an ID. Read through the comments here to see the specifics on how to create that. It basically tells you exactly what to do. And when you're done, the TypeScript errors should go away, but then we'll address this issue with having an any type here. Also, for simplicity, I've added this next user ID variable and added it to our users array just so that you can continue to use next user ID ++ like we were doing in the pizza app. And I've also shortened this users array just so that there's not quite as much clutter when we're console logging the array of users. Okay, you should be set up. Pause now and work on this challenge. We can pretty much just follow these steps exactly as they're said. So we'll call a new variable user, and I'm actually going to type this as a capital U user. The goal is to make sure that it conforms to the user object type. Okay, this is going to be an object, and the first thing I'll do is add an ID property to it. We'll use the next user ID ++ trick to get that in there. And then I'm just going to spread all of the properties of new user into this object. Now that I have a new user object, or a user object that is new, let's go ahead and push it to the array of users. We'll say this is users.pushUser and return the user object. Okay, now the TypeScript warning under user is gone because now this function is returning a user as the type would indicate it's supposed to. Let's clear out the comments here and do just a quick test. We're pushing Joe Schmo, who is a role of member, and sure enough, there he is at the end of our users array with, I might add, the ID of 3, which is what we wanted. This might be a good time to remind everybody watching this that this whole next user ID thing that we're doing, it's really just to drive our curriculum forward. You're very likely to have your database handling the whole ID assigning thing. Okay, now let's address this any type here. We don't really want this to be an any type because as it currently stands, we've disabled TypeScript checking for this, and I could just add a blah blah category or property to this object, and TypeScript's not going to warn us that this isn't going to work, or rather that it could really screw up our code. So what exactly can we do? Well, we just learned about the partial type, and it might seem at first glance that we could make this into a partial of user. However, the problem with the logic here is we want to make sure that all of the properties exist, and with partial, it turns everything into an optional property. Let me get rid of this blah property here. If I submit this as a partial, like this, of user, and then for some reason I don't supply one of the properties here, I have a problem. I've taught this function that it's going to return a full user, and as you saw, even before I deleted the role property here, we have a warning, and it essentially tells us that these are not going to be compatible. That's because we need to return a user, and our user property needs to have, up here, it's not optional to have an ID, a username, and a role, but our partial user type here, it is possible to not have one of those things because all of the properties are optional. Okay, so partial's not really going to work for us. There is a way clearly that we could make partial work, but we would have to do a bunch of extra checking inside of the body of our function, and that's not really the road that I want to go down. Enter the omit type. What does the omit type do? Well, it takes in a type, just like partial, but it also takes, you could call it a second parameter to that utility type, which will be a string, or potentially a union of strings. We'll see what I'm talking about in just a second. And those strings are the property names that we want to omit from this type. It's going to return a brand new type with the properties that we specified removed. It would probably be a great idea to go to the documentation on the TypeScript docs. You can click the screenshot that you see here, which should take you directly to the omit type docs. So what does this look like for us? Well, oftentimes, especially if you're only going to be using this utility type once in your code, you can just do it right in line. So I can use capital O omit, a set of angle brackets, and I first need to provide as the first parameter, you could say, the user type or the type that I'm trying to modify. And then just like in function parameters, I'm going to add a second parameter here, and that is going to be a string of the properties that I want to omit from the user type so that the type that omit returns will not have the ID property in it. Okay, why is TypeScript warning us about capital O omit? Well, we come to another point of some irony. The omit utility type is currently omitted by Scrimba. Well, more specifically, in reality, it's just that omit was introduced in TypeScript version 3.5. Scrimba is currently running on an older version that doesn't yet know what omit is. In the future, I'm going to be able to remove this whole caveat, but for now, I'm just going to show you a screenshot of what it should look like. So we have our code exactly like we see here. And notice that TypeScript is not warning us about anything. I guess as a reminder, TypeScript doesn't stop us from running our code. There are ways to set it up to do so, but I can hit save, I can open my console, we can see that our Joe Schmo user has been successfully added to our array. But let's look at what it's supposed to look like. If I were to, for example, comment out the ID property, we can see that we have an error on the user object. If we hover our mouse over it, we can see that the property ID is missing. That's exactly what we would expect. Now, I don't have a screenshot of this, but if we were to take away one of the properties when we're calling add new user, we would also get a TypeScript warning that tells us that we're not providing the correct type to our add new user function. It's going to have all of the properties of user, just minus the ID property. That way, our function can be in charge of creating the ID for our user object. Really quick, I did mention that you can provide either a single string or a union of strings. If for some reason I wanted to omit both the ID and the username, I would use a union character, which is the single pipe, and I would do another string literal of user, which tells it that I don't want this new type that omit is creating to contain either the ID or the user. In our case, that means it would just be an object with a role property. Again, TypeScript would be warning us here, but because it's not currently recognized by Scrimba, it's not giving me any other warnings. Okay, it's time for us to get back to our pizza app and apply what we've learned specifically about omit. So that's what we'll do next. Let's apply what we just learned about omit to our pizza restaurant app, specifically the add new pizza function. Your task is to fix it so that we use the omit utility type. Just like we did in the previous lesson, we want the user of this function to provide a pizza object that does have a name and a price. We don't want those to be optional because we need that information in our menu, but the add new pizza function will be in charge of adding the ID to it. While we're at it, let's go ahead and change this function so that it returns the new pizza object instead of void. I'm just going to add that here to the requirements. Okay, so make sure that you return the new pizza object with the ID added from the function, which means you'll have to change the types here as well. As a quick reminder, at the time of recording this, the Scrimba environment doesn't understand the omit utility type, so you will get a little red squiggly under the word omit, but you can safely ignore that and essentially any other TypeScript warnings you see here. In the very near future, Scrimba will know about omit, so I'll be able to just remove this caveat. The time is yours. Pause now and work on this challenge. Again, the reason we want to use omit and not partial is because we want to require that the person submit a pizza object with all of the other information except for this one property. Of course, with omit, you can omit more than one property, but in our case, we just want to omit from the pizza type. We want to omit the ID property like that. And while we're up on this line, we decided we're going to return a full pizza object from this function. Currently, we're not doing that, so TypeScript is warning us. Now, we have an issue with the way that our code currently is set up because we just told TypeScript that this pizza object will have all of the properties of pizza, but not the ID property. In other words, it's going to have a name and a price. And then we're trying to add an ID property on top of it. Well, we can't do that. So let's go ahead and create a new pizza object. We'll call this new pizza. We're going to type it as a full pizza object. And we'll set it equal to an object. We'll give it an ID property. We'll use the next pizza ID and then add the ++ for the next time around. And then we'll spread in all of the properties of pizza object. We'll get rid of this line of code. And instead of pushing pizza object, we will push new pizza. I can hardly believe how many times I've said the word pizza. And then as we described up above, we need to make sure we return the new pizza object. Let's hit save, and we are adding a few new pizzas up here. We're console logging the menu, and sure enough, we have the chicken bacon ranch, the barbecue chicken, and the spicy sausage pizzas added. For the time being, while Scrimba doesn't understand the omit utility type, I have a couple screenshots here. So this is from VS Code. We can see when we add the omit pizza type up above, TypeScript is happy with everything the exact way that it is. If we comment out ID, then TypeScript isn't happy. If you hover over new pizza, it tells you that you're not allowed to push this object to the menu because menu requires pizza objects, and this object that you're trying to push does not have an ID. So let's go ahead and put that back in. Similarly, if we were to come down and say remove the price from this first pizza that we're adding, we get a TypeScript warning that is a little bit cluttered here, but essentially tells you that the property price is missing. Now, for the sake of this course, I've decided that it isn't my objective to teach every single utility type that exists, because the documentation is very straightforward. If you want to peruse and see the different types that there are, again, you can click this link. This will specifically take you to the omit type, but it's all one long page in the TypeScript docs. So you can scroll around and see all of the different types there. But hopefully the idea is starting to be clear. These utility types perform really common operations on your existing types so that you don't have to do this work by yourself and introduce a bunch of repetitive code. Now, I did promise earlier that we would address this issue here where we have these angle brackets. And I think this would be as good a time as any to jump into that, which is a topic called generics. So that's what we'll be learning about next. I've mentioned this term generics a couple times throughout this course, and so it's finally time for us to learn what generics are. Generics in TypeScript are a really powerful tool that allow us to add some flexibility to the types of our existing functions, our already existing types, and other aspects of TypeScript code. You can kind of think of it like a function parameter. A function parameter is a placeholder for a real value that you use throughout your function, and a generic is a placeholder for a type that you can use throughout your function or whatever aspect of TypeScript you're using your generic on. This will make a lot more sense when we see an example. And generics use this bracket syntax with the angle brackets that we've seen a few times already in our code. Let's see a bit of a contrived example here, and then we'll apply what we've learned to our pizza restaurant app. Let's say we have a few different arrays like we have on lines 1, 2, and 3, and we want to create a really simple utility function that's called getLastItem. It takes an array as a parameter, and since this isn't really part of this challenge, I'm just going to say in order to access the last item of an array in JavaScript, we can just return the array at the index of array.length minus 1. Okay, we can see there's a red squiggly here for array. Hover your mouse over the word array and you'll see that it says the parameter array implicitly has an any type. TypeScript doesn't like when we have implicit any types. And so one cheater solution could be to explicitly type this as an any type, and of course that makes the TypeScript warning go away. But again, that's because the any type basically turns off TypeScript. This isn't exactly what we want. The problem is we can't say that this is an array of strings or an array of numbers because we don't know that. It could be an array of any item. Okay, well, what are we to do then? This is where generics come into play. As I mentioned, just like a function has parameters that are placeholders for values, generics are a way for us to have placeholders for whatever a type is going to be. Okay, let's check out the syntax for generics. When we're using it in a function like we're doing here, right before our parentheses with our function parameters, we're going to put in our angle brackets. And inside those angle brackets, similar to how we're doing with the function parameters inside the parentheses, we're going to put a placeholder for whatever type is going to be used with this function. A fairly strong convention for this is to use the capital letter T to represent type, but just to make sure that we're being explicit, I'm going to use the full word type with a capital T. Again, this is a placeholder type. The capital T type here is not referring to something that's built into TypeScript. This is a name that I chose. I could have just as easily chosen blah, 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 but let's not do that. Okay, well, what can I do with this now? Well, just like in a function, I can use the parameter throughout the code to represent whatever value array represents when this function gets called. I can use my generic type here to say the array is going to be of type capital T type, and it's going to be an array of that type. We've used the word type quite a bit here. I think it actually might be useful for us to call this something totally different. Like, let's call it placeholder. And actually, I'm going to call it placeholder type, because truly it doesn't matter what it is. Just like the name of your variable doesn't matter what it is, you can call it whatever you want as long as you're consistent throughout your code. Okay, great. Let's get your hands on the keyboard. This is going to be very simple, with more like a mini challenge than anything. This mini challenge is less about solving the issue and more about seeing what the IntelliSense pop-ups are when you hover over the different values. So call getLastItem on each of the 3 arrays that we have on lines 1, 2, and 3. You'll probably want to console log the returned value just so that something shows up in your console. And then the main thing I want you to focus on is hovering your mouse over different values in the code, just to see what the IntelliSense pop-up shows so that you can get a better idea of what's going on with generics. Pause now and work on this mini challenge. Okay, so let's get our console logs in here. We'll just do 3 of them. I'm going to use multiple cursors to save some time. We'll call getLastItem, and then we will put in our 3 different arrays. Okay, we'll hit save just to make sure that's working the way we expect. Great. We don't actually need to see the values right now, but let's hover our mouse over maybe game scores first. Okay, we can see that it is typed as an array of numbers. That's a type that was inferred by TypeScript because, of course, we didn't explicitly type it as an array of numbers. We can see the same thing with favorite things. It's an array of strings, and with voters, it's an array of object literals. Okay, now let's hover over getLastItem for this first call with game scores. It shows that it's a function called getLastItem, and as its type inside of the angle brackets, it shows number. And then it used that number type to infer that array, the parameter array, is an array of numbers. It also inferred that it's going to be returning a number as well, which we didn't explicitly place here. We'll do that in just a second. But if we hover over this second getLastItem, we'll see it does the same thing but with strings. And on the third one, it does the same thing but with that object literal with a name property and an age property. Doing this allows us to write types, and in this case functions, that can be a lot more flexible and still have some type safety without us using that any type, which just turns type safety off completely. Now this is bothering me a little bit that it says placeholder type. I'm going to go back to say type. And again, a really strong convention is just to use the letter T and other single letter variables, which is kind of funny now that I think about it because we tend to tell people not to use single letter variables for things. If you want to dive a little bit deeper into generics, there is quite a bit more than what we covered in this lesson, and frankly, more than we're going to cover in this Introduction to TypeScript course. But you can click on the screenshot here to go directly to the TypeScript docs, and it will show you some additional examples there that might help solidify the concept in your mind. Okay, now I mentioned that if you hover your mouse here, it says that it inferred the return type as a number, but we can also do that explicitly. However, I want this to be a challenge, even though I haven't really taught it to you yet. This will harken back to when we talked about explicitly typing function return values, but with a little extra twist as we are using generics as our type. Pause now and see if you can figure out how to explicitly type the return value of this function. In any other kind of function, we put a colon after the parentheses of our function definition, and we specify that this, for example, would be a number or something like that. In our case, though, because our function needs to be more generic than just using numbers, we can use that placeholder type, generic type here, as our return value. It's going to be a single item of whatever type this function is currently using when it's being called. Now, if we're really covering our bases, we might also want to ensure that we know this could potentially be undefined, as long as we spell undefined correctly, and that might happen if we have an array of length 0. All right, nice work. Let's move on to the pizza restaurant app and see how we might apply something like this to that app. The challenge that we're going to do in this lesson is purely going to be for practice's sake. I had to make a few changes to other parts of our code so that this very generic add to array function would work for our purposes in learning generics. So once we've completed this challenge, we're going to revert back to the old code. We can just think of it as a refactor that's gone wrong. I know the syntax for generics can be quite a bit confusing, so I wanted to make sure you got your hands on the keyboard again to type this out. Your challenge is to add types to this add to array function. As you can see from the example usage, it's essentially replacing what we had before with add new pizza and place order. This is primarily where I made the changes to our old code, which was using the omit utility type. Now we're just going to call add to array. We'll provide the array that we want to add to, and then the object that we want to add to that array. Once you've added the generic types to this function, the red squigglies under array and item should go away, and you should be able to console log our menu and our order queue and see these new items added to those. And actually, that reminds me, I'm going to get rid of these so we don't have any duplicates. And yeah, okay, pause now and work on this challenge. When we're adding generics to a function, right before the parentheses, we will add our angle brackets and we'll put our generic type. This time I am going to use the single letter T because that does tend to be a pretty strong convention that you'll see. With our array, we're going to assume that it is an array of type T, whatever that is. In our case, it's either going to be a pizza object type or an order object type, which we have right up here at the top. And item is going to be a single item of that same type. Maybe you can see why I'm saying this gets a bit confusing, because we have a bunch of new characters that usually we don't see in the middle of JavaScript functions. And here we can see the code says we're returning an array. I suppose that will just be the new array after it's been modified. And so if we hover over add to array, we can see that TypeScript is already inferring what it will return. So if we want to be explicit, we can say it's going to return an array of type T. Let's go ahead and console log our menu, and we'll do the same thing for the order queue. And let's see what shows up. Okay, it's a little hard to parse, but the first one that shows up in the console shows that Chicken Bacon Ranch was added as an option on our menu, and our order queue has just one item in it. That is the one with the pizza from the menu at index 2. Let's see, that is our Hawaiian. Perfect. We can see that the generic add to array function is correctly passing this type on. If we do something like trying to add another random property to this, we will get warned. And it says that the object literal can only specify known properties, and the property blah does not exist in the type pizza. Now, one thing before we move on, I do want to point out a little bit of a shortcoming when it comes to using our functions that are using generics. These example usages seem to be working fine, but if you remember on our order type, which we have up here, the status is only allowed to be the string ordered or completed. But check this out. If I come and I change the status, let's see, right here to something like done, well, TypeScript isn't complaining. The reason it's not complaining is pretty easy to understand, so we'll touch on it and fix this problem really quickly in the next lesson. We have a small bug in our code, and TypeScript is not warning us about it. That's where we added our status of done, even though done is not supposed to be a valid status for order types. So what exactly is going on here? Well, when we defined our generic function and we told it it was going to have generic types that it needed to use as the type throughout the rest of the code for this function, when we're calling add to array both here and here, we are assuming that TypeScript is going to be able to implicitly infer what type it needs to use as its generic type. If you hover over add to array right here on line 49, we can see that it says the generic type that it's going to take is an object literal with an ID that's a number, a name that's a string, a price that's a number, and a bunch of other things. It shows what the menu is typed as and everything like that. Let's do the same thing for the add to array on the order queue. Again, make sure you're following along and hovering your mouse over this, otherwise what I'm about to say will make absolutely no sense. The IntelliSense pop-up shows that it's a function called add to array. Its type is an object with an ID number, a pizza that is a pizza object type, and a status that's a string. Interesting. Our status is a string, but it's supposed to be the union of just these two literal strings. And that doesn't seem to have come through when we're calling add to array with the order queue. This is another case where it can be really helpful for us to explicitly type what the generic type we're passing into this function is. To do that, we essentially follow the same syntax that we had when we were defining the function. Right before the parentheses where we provide the parameters for this add to array function, we can explicitly type it with the same generic syntax of angle brackets. Now, this is where things can get a little tricky if this has been a bit of a challenge for you to understand. So let's make this into a mini challenge just to help solidify it. Okay, the mini challenge is to figure out what should be typed right here between the angle brackets as the generic type here on line 53. Pause now, enter in the type you think should be put here between the angle brackets, and when you do so, the red squiggly should limit itself just to the object here at the end because done is not a correct property. Pause now and give that a try. Because in this version of add to array, we are dealing with orders in the order queue, we have a predefined capital O order object. And when we add that in, now TypeScript seems to be able to understand that something is not quite right with this object. If we hover over add to array, now instead of having an object literal as everything, it has explicitly typed it as orders, arrays of orders, and so forth. And if we hover over here, we can see that the pop-up tells us the types of property status are incompatible. Specifically, done is not allowed here. It needs to be something like completed. Once we change it to that, awesome, everything is working, and TypeScript is happy. In fact, if you typed this out yourself, you could start to see, and this isn't going to be in the recording, but if you pause it and start typing the word completed, it does show up as an autocomplete option because TypeScript allows us to have these autocomplete options. I can just hit enter and finish off the now valid completed string as our status. It's probably not even worth making this a mini challenge. If I do want to explicitly tell this add to array what type it should be, I can, again, just put my angle brackets, type in capital P pizza, and everything will be happy there. If you want, you can see the difference now hovering over add to array. It tells us that the generic type is a pizza type, whereas when it was gone, it tried to infer exactly what that type should be, and it had an object literal. In our case, I don't think it would make too much of a difference because we don't have anything in our pizza type like we have here with our status. But once again, I think both for your own readability, the readability of other people looking at your code, and to help TypeScript out a little bit, it really does help to explicitly type your generic functions like this. All right, that was a lot of work. You should give yourself a big round of applause, pat yourself on the back, do a little dance, a little celebration. We are just about at the end of this first section of this TypeScript course. As always, play around with the code. I'm going to revert this back to the way it was. As fun as adding this add to array generic function was, I'm going to revert our code back to the way it was before because it was just better that way. Once you're feeling good, let's keep moving forward. And there we have it, folks. We are at the end of this first section for this TypeScript introductory course. Obviously, we haven't hit every last little aspect of TypeScript, but let's recap what we have learned. Of course, we started off by understanding basic, literal, and custom types in TypeScript. Then we moved on to how you can create optional properties in your typed objects. We learned about unions and how you can combine multiple different types into a single type, which naturally led us to learn about type narrowing so that we can narrow down which of those union types we're using inside of our code. As a side note, I feel like the code we wrote when we were learning about type narrowing is a great example of how TypeScript really helps you learn to think more like a senior developer, thinking of all the edge cases that you can while you're writing your code. Then we learned about a couple of the built-in utility types that give us some extra functionality in modifying our existing types in a really user-friendly way. And we capped everything off by learning about generics, which allow us to have additional flexibility inside of our TypeScript code. Now, as I mentioned, this doesn't represent everything that there is to learn about TypeScript, and something that I'm going to be doing with this TypeScript course is adding to it over time, so there actually is more to come. At the time that I'm recording this, what you've watched is everything that we have, but I do plan on adding a few extra topics in this section that you just watched, as well as adding entire new sections, more specifically one that's focused on how you use TypeScript while you're writing JavaScript code that interacts with the document object model, or the DOM. So if you haven't already, you should subscribe to Scrimba's newsletter, and whenever I make a major update to this course, I'll make sure that we email out an announcement of those updates. Until then, I've been your teacher, Bob Zarol. If you want to follow me on Twitter or X, you can click the link that you see here. My username is Bob Zarol, so pretty easy to remember. And until next time, good luck and happy coding.